In the last video, we forgot to talk about how decarboxylation can occur for malonic acids. So as opposed to having a beta keto acid, or you have a ketone on one side, carboxylic acid on the other side, you can have two carboxylic acids. So this is a dicarboxylic acid. So the same mechanism, basically, one of those, you can choose either one, will become CO2, and you will produce a carboxylic acid and, of course, CO2 bubbling away. Now let's talk about acetoacetic ester synthesis. This is acetoacetic ester. We already mentioned it a few times. Now, acetoacetic esters can be used to prepare methyl ketones of the types shown here. So meaning this right there, that alpha carbon can be, you can add multiple, you can add one R group, or you can do multiple R groups. So you can do monoalkylation, or you can do polyalkylation. So that's why it's a useful strategy. Now, so again, you can do mono or di-substituted, etc. Now, before we begin talking about this reaction builds on previous chapters. So for example, there is a part where we have to do alkylation, like that we did that today, but then there's part where we talk about hydrolysis of an ester. No need to know the exact the mechanism, just know the reaction. And then, of course, there's a strategy. The final part of the strategy is to decarboxylate. Now, here it is. This is a strategy. You want to alkylate the acetoacetic ester. We already did that before. You have to do hydrolysis of an ester, and you have to do then finally the decarboxylation. So let's look at an example. Here it is. We have an acetoacetic ester right there. And what you're trying to do, so this is step one, we're going to alkylate. So be prepared to write quite a bit here. Not necessarily lots of arrow pushing, but steps. So we have this as the OET. And let's actually write it underneath here, what we have. So we produce this in the intermediate. We produce the nucleophile. And this will attack that right there. Attack the primary alkyl halide, in this case, the ethyl bromide. So here it is, CH2, CH3. Very well. So here's what we started with. We started with the alkylating of the ester. Now, you can do another alkylation. If, let's say, we would like to produce the poly substitution or the di substitution, adding 2 R groups rather than adding 1. So we'll see that now in the next step. Okay, so you know that this will be deprotonated, making a negative charge just like that, and then attacking the CH3I, kicking the I out, and then you will have CH3. So this was added right here. Okay, now the next step is, since you have an ester right here, this is an ester, you're going to hydrolyze the ester. And if you recall, we talked about acid and basic acid-based hydrolysis or base-promoted hydrolysis. So in this case, we're going to use the acid hydrolysis. So this is step 2, hydrolysis of ester. Basically, what it is that you are changing the ester group. You're going from an OR to an OH. That's what a hydrolysis is. Again, that's a reaction we've done before multiple times. And the reagents for this are KOH, H2O, base promoted. In this case, instead, actually, we're going to produce the carboxylate because it's base promoted. So I'm going to draw it out, and here it is. Now, of course, this can be protonated very easily by an acid. And guess what? We can finally do step 3, which is decarboxylation. Get rid of this. And we will be left, just draw it all out. Let's just fix this one here. And of course, you can rewrite this way. CH3 on one end. Is your alpha carbon, can think of it that way. Now I'm going to just draw it for a second here so you can see it. Here is the CH3. I'm going to highlight this in different color to show the ethyl. Here's the ethyl. And of course, the H we don't show. So this is a way of using, oops, that's not what I intended to do, of using the acetoacetic esters to produce the desired ketone, as we've shown here. Now, the next video, there will be something similar. So just bear with us.